This is the work that was assigned on Wednesday, February 10th, and we're dealing with functions f of x equals x plus 9 and g of x equals x minus 9. That would be in number 17. And what we're looking for is for four expressions, four combinations of these two functions. The first would be to add them, f plus g of x. Then there would be to subtract them, find the difference, f minus g of x. To multiply them, get the product, f times g of x. And then to divide them, get the quotient, f over g of x. So really, all I need to do in each of these is to write the addition or subtraction or multiplication or fraction that would be the result of those two functions. So let me just stick some parentheses in here so I can fill things out in some colors for color coding sake. I'm not going to do this on all of them. I just want to do it on the first one so everything is absolutely crystal clear. So if f of x equals x plus 9 is red and g of x equals x minus 9 is green, I think they show up okay, then f plus g of x would be x plus 9 plus x minus 9. F minus g of x would be x plus 9 minus x minus 9. F times g of x would be x plus 9 times x minus 9, and f over g of x would be x plus 9 over x minus 9. Now that this looks thoroughly like Christmas, I'm just going to simplify everything. So x plus 9 plus x minus 9, the parentheses don't really add anything to this. So I've got two x's, and then the 9's cancel out. So it just equals 2x. This is a little trickier because I got subtraction and a minus sign. So if you were to distribute that minus sign, you'd see that this turns into minus x plus 9. Now those x's cancel out, and those 9's combine, and you actually have 18. Not even a function of x anymore, it's just 18. For this product, you'd have to FOIL them, and when you FOIL x plus 9 times x minus 9, you get x squared minus 9x plus 9x, cancels out, times, so 9 times negative 9 is minus 81. Last of all, this cannot be simplified. Now, something like this can only be simplified if there is a common factor. If it had been something like this, x squared minus 9x over x minus 9, that you could simplify because they both have an x minus 9 in it. Observe. See, like those two are equal to each other, and that you could cancel out. But x plus 9 and x minus 9, they're never going to cancel out. So it turns out that the answer to 17 is 2x, 18, x squared minus 18, and just plain old x plus 9 over x minus 9. So that's number 17. That was probably the easiest, so it's the one that you probably have the least to worry about. But as we go on, it'll get a little trickier. So number 19 is up next. And number 19... not number 9, number 19, says that f of x equals 2x squared and g of x equals 8 minus x. Okay, so adding them together, I'm not going to do color coding anymore. I think I've made my point with that. Also, it's just a pain capping and uncapping the markers all the time. So f plus g of x would be f of x plus g of x. The parentheses don't really do anything here, so I could just take them away. But then I'd want to rewrite this in standard form, which just has the highest power of x first, followed by the next power of x, followed by the constant. So that's essentially just, dotting your I's and crossing your T's there. It's proper format. The difference, f minus g of x, would be equal to f of x minus g of x. Put it in parentheses because we have a similar situation as before where we have to distribute that minus sign. In this particular case, we'll end up with 2x squared minus minus, that would be plus x minus 8. Okay, next up, the product. F times g of x would be f of x times g of x. In this particular case, we would just have to distribute that. And so 2x squared times 8 is 16x squared, and 2x squared times x is 2x cubed. So that would be minus 2x cubed. Okay, well, last up, the quotient f over g of x would just be a fraction that has f of x on the top and g of x on the bottom. Now, again, we've got a fraction, and we might ask the question, can this possibly be simplified? I have another strategy for you to try to answer that question. If that can be simplified, it means, actually, let me write this out. If 2x squared over 8 minus x can be simplified, that means that the problem 2x squared divided by 8 minus x has no remainder. And that also means the graph has no asymptote. So, if I graph 2x squared over 8 minus x, and there's no asymptote, it means that that division is possible without a remainder, and it can be simplified. But if there is an asymptote, it means, nope, can't be simplified, so just leave it the way it is. So what I'm going to do is I'm going to pull up everybody's favorite graphing calculator program and just put it in. So if I were to put in 2x squared divided by 8 minus x, we have an asymptote. So if you tried to do 2x squared divided by 8 minus x, you would get a remainder. The remainder produces that asymptote, so no, this cannot be simplified. Okay, thank you very much, Desmos. You can go away now. So that means that our answers to number 19 are, for the sum, 2x squared minus x plus 8. For the difference, 2x squared plus x minus 8. For the product, 16x squared minus 2x cubed. And for the quotient, 2x squared over 8 minus x. Almost through with this section. Now we can do number 21. Number 21, definitely the hardest, and I think this is the one that most people were asking questions about while you were working on it yesterday. So f of x is equal to x squared minus 1. G of x is equal to x over x plus 1. Now, for the sum, f plus g of x, again, it would just be this, x squared minus 1, plus that, x over x plus 1. But we have an issue here. That's a fraction and that's not. I could turn this into a fraction by putting it over 1, but if you're going to add it, then you're going to want to have a common denominator. And to have a common denominator means that you need to take it and multiply it by the same thing on the top and bottom. And in this case, it's going to be x plus 1 over x plus 1. Now, x squared minus 1 times x plus 1 would be equal to, foiling, x times x squared is x cubed. X times, or I should probably do it the other way, x squared times x. X squared times 1 would be x squared. X squared times x, I already did that one. Minus 1 times x would be minus x, and minus 1 times 1 is minus 1. Yeah, x cubed, x squared, minus x, minus 1. Okay, just making sure I got that right. Okay, so it would be that cubic function on the top, and then x plus 1 on the bottom. So I could rewrite this sum as, instead of this, right, that's in lowest terms, this has in common denominator, x cubed plus x squared minus x minus 1 over x plus 1 plus x over x plus 1, which is quite a lot, but you know that if you were to do this, you could just kind of merge the fractions and it would be the same denominator. So it's x cubed plus x squared minus x minus 1 plus x all over x plus 1. Well, this x and that minus x cancel out, and that means what we're left with is x cubed plus x squared minus 1 over x plus 1. To see if that can be simplified, we just use the same trick we used before, and I were to type in x cubed plus x squared minus 1 and then divide all that by x plus 1, and it looks like there is an asymptote. So that means this can't be simplified and we don't have to worry about that. Okay, so here we go. That was the sum. Now let's do the difference. F minus g of x is going to be f of x minus g of x. And what do you know? I need a common denominator again, so I can just replace this with that, do the same problem, except this time it's with a minus. So there's that, but with the common denominator of x plus 1, subtract x over x plus 1. And now instead of canceling out that minus x, it combines. So that means it's x cubed plus x squared minus 2x minus 1 all over x plus 1. Okay, now we have a more complicated, no, it's not really more complicated, but we have a different cubic function, and we need to see, does this one simplify? Once again, Desmos is going to do a shortcut for us. I just need to put a minus 2x in here. And nope, still has an asymptote, still doesn't simplify, so we are good there. So let's see where we are. This is the sum. This is the difference. And that took up enough room that I need a new sheet of paper for the products. F times g of x would be equal to f of x times g of x. So we're multiplying something by a fraction, which essentially means this is the top of a fraction over 1. And so it's top times top and bottom times bottom. So if you were to do x times x squared minus 1, it would be x cubed minus x over x plus 1. Okay, we've been doing the Desmos test to see if it can be simplified. So I'm going to plug in x cubed minus x over x plus 1 and see if there's an asymptote. If I put in x cubed minus x and divide that by x plus 1, I get a parabola. Oh no, do you know what that means? It means it can be simplified. Because look, you've got your x cubed over x. The end behavior, there's 2 more x's on the top, so it looks like a parabola. However, if I go all the way into -1, it's undefined. Wait, where is it? Oh, I went past it. There it is, see? That's undefined. That means I can simplify this. Now, if I were good at math, maybe I'd be able to just spot the thing that's the same about it, but this one is just a little more complicated than I can just pop out of my brain. So, as much as I might not want to, the best way that I can think to do this would be to actually do x cubed plus 0x squared minus x plus 0 divided by x plus 1 and just see what I get. If you have another way to do this, please do it, because you know what I mean. This is a lot, but it's what I have to do. Maybe you can do something different. X goes into x cubed, x squared times x plus 1 is x cubed plus x squared. Subtract that. X cubed minus x cubed is nothing. 0 minus x squared is minus x squared. Bring down the minus x. X goes into minus x squared minus x times x is minus x squared, minus x times 1 is minus x. Subtract that. It's all the same. I get 0. And so there's nothing but 0 left. It's all done. Is that really true? Is it really true that x plus 1 times x squared minus x equals x cubed minus x? Is that right? Is that really right? I have to check. This really seems suspicious. X times x squared, x cubed. X times minus x is minus x squared. 1 times x squared is x squared. Plus 1 times minus x is minus x. Would you look at that? Cancels. That's right, x cubed minus x. I didn't believe it when I saw it, but I'm not willing to risk that the solution I give you is wrong, so I do it the hard way and then I double check. Math, man. Okay, so now that we know this can simplify to that, it means that the product is x squared minus x. If you got that, and that was your answer, okay, that would be like answering with a fraction not in lowest terms. That is in lowest terms. Okay, there's one more to do with this. I think I will need a third sheet of paper for this, just to make sure I've got the room. That would be the quotient, f over g of x, and that is equal to x squared minus 1 over that. Whoa, a fraction in a fraction. Well, you know that a fraction is equal to a division problem. And you know what to do when you divide by a fraction. you flip and multiply. You know, like that. You flip the fraction, and then you multiply it. So let's multiply x squared minus 1 times x plus 1. Let's FOIL that. X squared minus 1, x plus 1. X times x squared is x cubed. X times minus x is minus x. X squared times 1 is x squared. 1 times minus 1 is minus 1. So on the top, it's x cubed plus x squared minus x minus 1 all over x. Well, this clearly cannot be simplified because there's no x on here. And hey, that looks familiar. Isn't that, oh yeah. That's what that was back when I needed to put it in lowest terms, except it has x in the denominator instead of x plus 1. Anyway, that's the quotient. So that was definitely the most complicated of the three, but just to make sure that you can see those one after the other, the solution to the sum was this, the difference was that, the product was, sorry I didn't circle that one yet, and the quotient was here. All right, now there were a couple other odd exercises. This one was to find the composition. So let me set up for that. So for number 29, looks like it's giving G and H this time, not a problem. I almost just wrote F by habit. G of x is equal to 4x. H of x is equal to 2x minus 1. So to put G inside of H and H inside of G, the first one, remember I hate this notation, G, O, H, is equal to G of H of x. And that means that I would be putting that inside of there. So that would be 4 of 2x minus 1. That distributes and you get 8x minus 4. If you were to do HOG, H-O-G, that would be G inside of H, then you'd have 2 of something minus 1, that would be 4x. So that would be 8x minus 1. Okay. Let's see if I can knock these out really quickly. Number 31, we've got G of x equaling x plus 2 and H of x equaling x squared. So if I were to do G of H of x, I would be doing something plus 2. I would just have to put an x squared in there. So it's x squared plus 2. If I were doing H of G of x, then I would have to be doing something squared. That would just be x plus 2, which I don't mind leaving like that. It doesn't really make it any better to say x squared plus 4x plus 4. I think that's just fine. Lastly, number 33. Number 33 says G of x equals 2x and H of x equals something a bit larger, x cubed plus x squared plus x plus 1. So if you were going to do G of H of x, that means you're doing 2 of something. You're doing 2 of that. And while you could leave it like that, you might also distribute the 2. That actually looks kind of cute with all the 2's in a row. It's like a family of ducks. I don't know. And the last one, the very last one, h of g of x would be something cubed plus something squared plus something plus 1. You just have to put that in there. And so if you were to simplify this, you would get 8x cubed plus 4x squared plus 2x plus 1. And that is 33.